And hello, welcome everyone to this video of natural convection. So, in the last video we got ourselves to this point where, okay, we have our velocity, momentum equation, our energy equation, all in the right form. Yeah, so we have literally integrated those equations across the boundary layer, and this is what we have. Okay, so next thing to do is just to substitute all of these temperature profiles in. So I have not prepared anything, so I'm going to do it like live before you. Okay, so let's do the momentum equation first. Okay, let's do a momentum equation first. So for momentum equation, we'll have this equation. So what do you need to substitute in? We need to substitute in v squared. So let's substitute in v squared first. So v squared equals to this vy squared. Okay, so the exponential thing will also need to be squared. Okay, and I mean all of these things here will be squared accordingly. Okay, let's see. Have a square here. As you can tell, it's gonna be very messy when we try and put this in and then so-called integrate everything out. Okay, so just for a reminder, actually I kind of forgot this. Okay, anytime you square the exponential, you just multiply all the powers there by 2. Okay, so let's do that. We'll need to just shift the 2 in. It's nothing really that big of a deal. I think the more troubling one will be this thing. Okay, the troubling one will be this thing. I don't really feel like expanding the thing. So let me bring the 2x in, and for this term here, we will do our a squared plus 2ab plus b squared kind of a formula. Yeah. Okay, so I need 2 exponential fraction. Okay, so it's 1 squared minus 2ab minus this plus the exponential whatever squared. Okay, I hope I got it right. Okay, so 1 squared minus 2 times 1 times this exponential term here. Okay, plus exponential 2x over delta t. Okay, maybe I got an extra bracket somewhere. I don't need that many brackets. Yeah. Let me get rid of the brackets. Okay. And so now we are in business. So we sort of have to integrate all of this. Okay. And before we integrate, we might need to multiply this exponential term into all these 3 terms so that we'll have a bit of an easier life when we try to integrate. So I'll just multiply this exponential term in. There's 1, there's 2, and that's 3. Okay, so after that I'll just simplify it by multiplying things in. So when you have powers like this, you just add the exponential powers. 2x over delta p minus 2. This thing will be to the 3x power. 3x power. And the last one will be 4x. 4x power. Okay. So it's not as bad as I thought. It's just a little tedious. Yeah, so this is what a v square should be like. And integrating this with respect to x should not be too much of an issue. Okay, so yeah, all right. Let's start the integration. Yeah. So let's see, and we also need to differentiate it by y after that. Okay, but of course we may not. Maybe we can just leave it implicitly, so we just leave the derivative here. Then we'll have to sort out the terms on the right hand side. But let's just integrate this out first. Okay. So we'll just bring out this v square y term out. Yeah. And then we'll need to just apply the integral to each of these three. So 1, okay, that's 1 time, 2 times, and 3 times. Again, I use the copy and pasting. Here I factorize out the vy square in front, outside, and I will just integrate each of these terms individually. So integrating exponential is pretty simple. You'll just have the exponential itself, divide by whatever's the factor inside. Okay, whatever's the factor inside. Okay. So let's do that. So we have the exponential itself. Then we'll divide it by this factor inside. So outside we'll just have minus delta p over 2, for example. Okay. And of course we will need to apply limits, which I will do it later. Here we'll have minus delta p over 3 on the outside. Okay, so fraction. So we have a minus in front and a minus inside, so you might get careless here, so pardon me if I do get careless. Minus 2 delta p over 3. Alright, and then one more over here. Fraction minus delta p over 4. And then of course I will need to evaluate this at x equals to 0, and then of course at x equals to this big X. Big X is a value of x big enough so that we have velocities in their free stream values. Okay, free stream values. Okay, now so how are we supposed to do this? Okay, how are we supposed to do this? Let's evaluate these terms. Okay, so and before that, let's multiply in some of the negative signs, because I think the negative signs are already all over the place. Okay, so let's bring the minus sign out. To bring the minus sign out. Okay, so this minus minus will become a plus. That's the center one. Just be very careful with those minus signs. The first term will have a minus sign in front, and the last term will also have a minus sign in front. And that's all. Okay. Now that is settled, let's try. Okay. First, of course, we will need to evaluate things at x equals to x, right? And this is big X. So first evaluate at what? X equals to big X, where big X is such that the velocity will be at free stream value. Okay? The free stream value is just where this velocity is 0. Okay? So, we can say, okay, we can think of it this way, right? When we have x being very big, x is large, the terms in the bracket drop to near 0. Okay, it's not 0, but it's near 0. Okay. So what am I trying to say here? Okay, when you have these terms, this is approximately 0. Okay, I will just put big X over here. Hopefully it does not confuse you. But I'm just saying this X is big enough so that all of these terms will be very near 0. Okay? So, I'll just leave the terms as it is here. Because we cannot just get rid of it yet. You have to compare it to something else. You have to compare it to something else. So it has to be small with respect to something else. And once there's something else, it's when this x is equals to 0. So let's also evaluate it at x equals to 0. So when x equals to 0, this exponential thing will just be exponential to the power of 0. Okay? Which means that all of these are just like unity, 1. Okay? So this will not be approximately 0. Okay? So this is the terms inside the bracket when x equals to 0. Okay, so now we'll have to do some subtraction. Okay, the integral evaluates to, okay, so the terms in the bracket, right? We want to get this whole thing minus this whole thing here. Okay, it will be a bit long, but it should not flow over the whole page. Alright, so okay, let me deal with the minus signs before we continue. Okay, so I have a plus here. I'll multiply everything in by -1. So that's a minus, will be gone. That minus will be gone, and the rest will turn into pluses. Okay, yeah, that's how we would want to do things. Okay, and I think yeah, we can more or less just add these things up. But what am I saying here? Okay, now we have something to compare this small term here too. So these terms should be small in comparison to these terms. So I'll just drop out. I will just drop out all the terms over here because these are so small. I'll just drop them out. And what we are left with is this term. Okay. So I don't feel like doing too much math, so let's do. We add half minus 2 over 3 plus 1 over 4. Half minus 2 over 3 plus 1 over 4. And Wolfram will do it for me. It will have a 1 over 12. Okay. I hope I'm doing it right. Yeah, but... Okay, let's do fraction 1 over 12 delta p. Yeah. Okay. So at least we have the integral actually reduce this very complicated thing down to something a little bit more simple. Okay. Okay, and I think I might have messed up something. Ah, yes, I did. Okay, so here's the deal, man. Here's the deal. Okay, so when I expanded this thing out, I kind of forgot to account for the fact that, well, we have we have two different boundary layers here, and yeah, again, I was caught off guard by these careless mistakes, so do pardon me. Okay, but again, the principles are the same. We just add the powers together. Hopefully, we don't have to take too much of, yeah. So, I'm just going to correct some of the careless mistakes here. So, this is here. And I'm not just going to add all the powers together. So, okay. The first one will be the same. The second one, we should not be fraction 3x, it will be 2x over delta p. I'll put minus x in front. Okay, plus fraction x over delta t. So there are two boundary layers here. You gotta take very careful note. So 2, okay. Plus fraction 2x over delta t. Okay. Pardon the mistake. So okay, 2x over delta p, 2x over delta p, 2x over delta p, x over delta t, 2x over delta p, 2x over delta t. So now I just have to replace. Okay, I have to replace it. And obviously, when we integrate, it's not going to be so smooth. Okay. Oh, okay. I think I inserted an extra x over here. Yeah, I think I'll just factorize that out. I think I'll factorize the 2 out. Okay, well, maybe not. I'll not factorize the 2 out. Okay. Ooh. Okay, hopefully this helps you to see better. I'm going to... Yeah, you can skip ahead if you think this is boring, it's not worth the time, which I totally understand. So you can skip the video ahead. I'll just keep running the thing and yeah, until we get there. Okay. So now in the integrand, we'll need to change the powers of it. So this is 1, this is the central one, and then of course we'll need to change what is left in front. Okay, what is left in front? Okay, so great. let's combine these two into fraction. Before we continue, combine into single fraction. And then we can invert it. So fraction okay, we'll have this is equals to fraction 2 delta t plus delta p over delta t delta p. Alright, now that looks a little bit better. Then the other thing we'll just do the same as well, except instead of +1 it becomes +2. So it's 2 plus 2 and we are done. We're there. Okay, so let's try to push all of this down and push all of this in. Alright, so we'll have to invert these fractions. Okay, so now we are ready. Okay, we'll just substitute back. Okay, so the second part. Okay, the second part will have some sort of a, the minus sign will still be there. I will just have delta p delta t on top. Delta p delta t on top, and at the bottom I have 2 delta t plus delta p. Okay, that's one correction. And then this little fella at the end will also we also need to correct some of that. Again, the signs are the same. I have a delta p delta t on top and 2 delta t plus 2 delta p at the bottom. Okay, so the next part is just settling out those minus signs, which shouldn't be too much of an issue, hopefully. So this one becomes a plus and the other one becomes a minus. Okay, so I have a minus here, I have a plus here, and this line is kind of redundant. Okay, so again we are going to evaluate all the terms in the bracket up to the boundary layer part. So I will just put a big X inside there. And I'll just say that all of these terms, yeah, still equate to 0 or very near 0. Okay, and otherwise, when I evaluate it at x equals to 0, all the exponential terms just drop out. Again, this is not equals to 0. This is just what we are evaluating in these terms, and x equals to 0. So now looks like we have looks like we have a lot of terms here. We will need to so-called collect them together later on. Yeah. Phew. Okay. Now that's a lot of work. And yeah, basically again, I will say the same thing. All of these things here, they're very small. Okay, they're very, very small in comparison to the terms here in the bracket. Okay, so we have some spillover, which is unfortunate. Let me bring that part down. Okay, and let me settle the minus. Okay, let's just do this. All right, you get the idea that this first part will just drop to 0. Okay, compared to the second term. So I will just do the approximation right now, so that I don't have to keep copying. Approx this, and that will be equals to, okay, the minus will cancel out. The minus sign will be in the middle. And the plus sign will be the last one. Okay. Alright, so okay, this will be it for now. Next time we'll just I guess we'll just do some simplification. We'll get this combine these fractions together, and we'll probably do the same for anytime we have this big integral bit, it becomes a little bit of a headache, as you can tell. Okay, but that's what I'll have for now. I'll stop here. Let's continue on in the next video. Thanks for watching.